In this problem, we are given a square mat foundation which supports the 4 columns as shown below. We are tasked to compute the direct distance between the resultant and the smallest load, which is this 8 kN force. And to solve this problem, we apply Radian's theorem. So let's assign some variables to these values. This here is F1, this one is F2, and this one is F3 and F4. And then let's assume that the resultant force is located right here, where the distance along Z, this is bar Z, and this one here is bar X. Let's call this resultant R. And using Radian's theorem, R times the distance from X, that's X bar, equals to the summation of individual forces, that is F1 times X1 plus F2 times X2, and so on. We can solve for the distance, that is bar X. So for the resultant, that is just the summation of all forces, that is 40 plus 12 plus 8 plus 20. There is a value of 80 kilonewtons times bar X equal to F1 of 40 kilonewtons, and this distance along the x-axis, let's take this point here to be our reference coordinate with a coordinate of 0, 0. So x of 1 here is equal to 0 for force F1, and for F2 that has a value of 20 kilonewtons. Its distance along the x-axis, that is 4 meters. And then plus F3 of 8 kilonewtons times its distance along the x-axis, that is equal to 4 meters plus 6 meters, equal to 10 meters, plus F4 of 12 kilonewtons times its distance of 4 plus 6 meters, that is 10 meters. Now we'll solve for X bar. So we have 80 times X equal to 40 times 0 plus 20 times 4 plus 8 times 10 plus 12 times 10. That is equal to 3.5 meters. Now to solve for its distance along the z-axis, let's just replace x bar with z bar, and all x has to be z. And the distance for the 40 kilonewton force going from the origin along the z-axis, that is 0, since it is located on this point here. And for the 20 kilonewton force that is located 5 plus 5 meters, that is 10 meters. And for the 8 kilonewton force, that is a distance of 5 meters along the z-axis. And for the 12 kilonewton force, that is 0. Now we can solve for z. So we have 80 times z equal to 40 times 0 plus 20 times 10 plus 8 times 5 plus 20 times 0. Solving for z, that is equal to 3 meters. And since the question is asking for distance between the resultant and the smallest load, which is this 8 kilonewton force, so let's try to draw this into our figure. The resultant is located 3.5 meters along the x-axis, so let's say it's right here, and then 3 meters along the z-axis. So let's say that the resultant force is right here with a value of 80 kilonewtons. And to solve for the distance between the resultant and the smallest load, let's plot the coordinates for the smallest load, which is right here. That has a x coordinate of 10 meters and a z coordinate of 5 meters. And for the resultant, that is located at 3.5, 3 meters. Now we can use the distance formula to solve for the distance between the resultant and the 8 kilonewton force, that is D equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So for x1, which is here, and this is our y1, and this is our x2 and our y2, we can plug in the values directly into our equation. So we have 3.5 minus 10 squared plus 3 minus 5 squared. Solving for D, that is equal to 6.8 meters approximately. And this is our final answer.